Hello, my name is Harrison Leary, and this is my Physics 2 Lab 3. So, for an introduction, the goal of this experiment is to observe how magnetic dipoles behave in the real world, and then model this behavior in GlowScript to determine how the magnetic moment is. Then, the results of this experiment were that the magnetic moment of our singular magnet was 3.947 amp meters squared, and the N value we recorded was negative 2.8239. And the physics principles we used were this formula for the magnitude of the magnetic field of the bar, which is this relation Kr to the N, and then Biot-Savart law for the magnetic field of a dipole, shown below. So then for the data and calculations, we recorded everything using a magnetometer on a phone and recorded all the data you can see in the yellow, blue, and green boxes. And then we graphed the relation of this data on the right, where you can see our line of best fit of y equals negative 2.8239, which is our N value, times x minus 14.052. And so that constant there is our k value, the coefficient on the x is our n value, and that relates to the formula shown below. The natural log of bx is n times the natural log of r plus the natural log of k. So based on the data, as the distance grows, the x component of the magnetic field approaches 0, and because of that, the x component increases as it approaches the observer. So then for our model, after formatting everything in GlowScript, this was the result, and all of the distances for observation and everything are shown on the left. And then some of the discrepancies we had in recording were that the magnet within the phone led to slight differences in data, and also a laptop was nearby that we were recording on, and we did notice slight changes in the data when the laptop was moved, even when it was on the other side of the table. And the magnetometer was only estimated to be pointing north, because that is something very hard to get precise when you are just using the phone resting on a table. So then for my code, in the top left you can see my code for the Biot-Savart law, and then everything else on the left and the upper right are my vectors for all the observations, and then drawing the arrows for those observations, and then finally formatting everything for the scale. So in conclusion, uh, if you hadn't oriented your experiment to compensate for magnetic north and had instead laid out your meter stick at some intermediate angle with respect to Earth's magnetic field, how would your results have changed? So if we had done that, we would not have been able to isolate the magnetic field recordings to just the positive y-axis, and thus we would have to account for Earth's magnetic field in our recordings, which would make it much more difficult to calculate the magnetic dipole moment. And then what if you were to stick two identical magnets together end to end and run the experiment again? How would you expect your measurements to differ? So this would make a change in the magnetic dipole moment, because by sticking two identical magnets together, we were essentially just making one larger dipole, and as these are two different dipoles that we are using in our measurement, the magnetic dipole moment would change. And that's everything. Thank you.